Hello, this is the first in a four-part series on the self-driving codebase. So today we're covering the primitives, the infrastructure building blocks that make background agents possible. In the next three sessions, we go into deep dives on specific use cases like how to automate CVE remediation, how to migrate CI pipelines at scale with fleets of agents, and also how to modernize legacy Java and COBOL code. We put together background-agents.com as a resource to map out this space of what background agents are, how they work, and where the industry is heading. If you're watching this, you've probably already seen the site. If you haven't, go and take a look. But today we want to go one level deeper into the actual primitives, the infrastructure, the building blocks that make this work. So we've been framing this also talking about self-driving code bases, which is really kind of where the industry feels like it's moving now, where we have engineers that work on the loop, designing feedback rather than necessarily in it, writing every line of code by hand. Instead, we're observing, setting constraints, and verifying outcomes. So companies like Stripe and Ramp are already moving this way and publish some very nice blog posts where they talk about their reference architecture, about how they're building background agents and what that looks like for them. So before we get into it, Chris, I'd love to hand over just a second for you to introduce yourself and give people a sense of what is your role, what does owner do, and why does that matter for today's conversation about background agents?
Hi, so my name is Chris. I'm the CTO and one of the co-founders at Ona. And we've been building Ona from day one to accelerate the way people ship software, to make it easier, make it more convenient, make it faster. And over the years, we have found that the first thing you need to solve is the development environment, the box in which the development happens. And only then can you solve the how it happens.
Love also from your side, Chris, if you could kind of define from your perspective, like what separates a background agent from a regular coding agent, and how does that distinction matter?
To me, a background agent is an agent that can do work when I'm not looking. So when I close my laptop and the work continues, that already happens in the background. If I can fire something off and it happens in the background. Now, that's most agents. A bit more specific is agents that are able to pick up work by themselves. So specifically agents that, for example, observe the logs of your production system, or that react to tickets in your bug tracker, or that once every hour update your dependencies, or whatever it is. Like agents that, through observing their environment, automatically kick off work and then proceed with that work up until a point where human intervention is necessary, if ever. Typically, that's when a PR is raised. But up until then, operate autonomously. I can, of course, observe what they're doing and potentially give guidance if needed. But very fundamentally, they're agents that happen that do work while I do something else.
Okay, so Chris just defined what a background agent is, which is an agent that picks up work by itself and operates autonomously until a human needs to step in. Now, to make that real, there are three infrastructure primitives that you would need. Everything we're going to talk about today maps back to these things, so I want to name them as clearly as I can. The first is compute, right? So every agent needs its own isolated development environment. Ideally, that's a VM as opposed to a container that's sharing a kernel for security and reproducibility reasons. Ideally, that VM has your repository cloned, your dependencies, secrets, and everything done automated so you can spin that environment up and then you can destroy it after. And then with that, you also need orchestration. So you need to be able to launch hundreds or maybe even thousands of these in parallel, which obviously depends on your organization size and how many different code repositories that you have. The second of those is events. So something has to trigger that work. That could be a pull request being open to trigger a review, a CV advisory being published, and that's getting picked up by an agent, and then it's going to patch that vulnerability, or maybe it's running on a cron schedule, running nightly, something like this. This is the piece that separates background agents from just running, a coding agent in a terminal, because there's no human prompting the agent here, which allows you to get to this idea of a self-driving code base. And the third is governance. So once you have autonomous agents doing real work in your infrastructure, you then need to control who can trigger what each agent has access to, and then you need to have audit trails. So should something go wrong, you can understand what actions were taken and you have visibility. So it's these three: compute, events, governance that are the building blocks. And if you're missing any one of them, you don't have this foundation for the self-driving code base that we talk about in the microsite. If you don't, then you have effectively just a coding agent that's running somewhere. And that is a nice first step or on ramp, but it's also a different thing. It's not really the full self-driving code base that we're talking about. And I mentioned at the start about sort of Stripe and Ramp because I want to introduce those also as sort of references. So Stripe has a platform and their agents they call minions, and they say that they're now merging over 1,000 sort of agent-based PRs per week. And Ramp is, saying they're also responsible for about 30 to 40, 50% of the merged PRs across Ramp as a whole. However, one thing that sort of strikes me is when you look at Stripe and Ramp, like they have, thousands of engineers, years of sort of developer experience, investment. Is that sort of reasonable to sort of replicate for a normal company? I know that lots of people are now looking at that thinking, okay, how do we do that within our organization?
I have a sign behind me that says, we don't do this because it is easy, but because we thought it was easy. That's a warning sign. It should be yellow, really. On the surface, it looks so easy to replicate. You read those blog posts and you go, how hard can it be to spin up a virtual machine? Once you get into it, you realize that there's a lot of problems you need to solve to actually make this work well. And we haven't even touched on security. Just being able to stand this up reliably, observe it, and not bleed cost because you forgot to shut down a VM or an agent went rogue and no one was there to observe it is already more difficult than it seems at the surface. And then there is security on top of that. You need to make sure that there are the right permissions and identities. You need to think about lateral movement as you now have these multiple intelligent things that can work on their own. There have been a number of studies come out, most famously the MIT study that indicated that a high percentage of AI projects fail. And the asterisk that a lot of folks forgot to report in their news articles was this high percentage only applied to AI projects that were homegrown. And the ones that were established software was bought, those succeeded far, far more often. So there is data and precedents that suggest that building a platform like this is feasible. Ramp has clearly shown that, Stripe too. But as you pointed out, Ramp and Stripe are huge organizations, very, very forward, modern organizations that are capable of pulling that off. That does not necessarily generalize.
And then from your perspective as well, so obviously in creating this site, it became apparent to me that there is also a unclear amount of definition about if a background agent actually has to run in the cloud. From your perspective, then, do you think you can get the same benefits from a background agent from not running in the cloud? And are there specific benefits for doing that?
I think one way you could ask that question is, would you host your personal website on your laptop? You can. Of course you can. Many have fiber. Bandwidth is not a problem. Latency probably is not a problem. Uptime might be. So when you're traveling to your next Starbucks, your personal website would be down. The question here, I think, is very similar. Yes, you can run background agents on your laptop. I mean, OpenClaw and the likes are a form of background agents, and they have clearly demonstrated that. Well, laptop or Mac Mini, I guess. The question is, should you? And you do not get the same quality from running these things locally. One, the horizontal scalability clearly isn't there unless you're going to run to the Apple store and buy a lot of laptops every so often. And two, there is an uptime question. It is just so much easier to provision and continue to run resources in the cloud than it is locally. So you can do it, but I don't think you should.
So, if the laptop isn't the right place for background agents, the next natural question is what about the infrastructure that I already have? So, a Docker container in Kubernetes, an ECS task, a CI runner, are those good starting points for a POC?
That is for sure one way. So if you're more interested in how the sausage is made rather than eating it, I guess, then this is one way. You can, of course, take something like Claude Code and stick that in a GitHub action, put an Anthropic API key into the mix, and the thing is running. This isn't quite the experience, though, you can get from a platform that is purpose-built. So you'll get some agentic work done in the background. And so in that sense, you have built a background agent. But what you're missing is the interaction with that agent. Just because it runs in the background doesn't mean you never want to see or hear from it. Again, other systems like OpenClaw have shown that there is some communication that needs to happen. Now, would you want to code through Telegram? Probably not. So there needs to be a richer interface to that background agent.
So one primitive that we talked about is this idea of events with background agents. And I believe that's also coupled with this idea that agents need to run effectively in the cloud. And a good parallel to draw on is continuous integration. Now, when you join a company, you wouldn't expect to run your test suites, your linting, all locally. You might do that before you push, but you always expect when you go to a pull request, you get the little green check mark because your pull request is then passing because some centrally running CI is running. The same is true for coding agents. And if you're running them on your machine, you're running them in parallel, you do start to get to this breaking point where you start to feel that if you as a developer are not prompting these agents anymore, they're not doing any work. So in order to graduate to the next level, then you need to start thinking about how do I run these proactively? And you can experiment with that on your machine if you wanted to. But then if you're trying to get to this idea of a self-driving code base in a professional setting, you don't want to have your device responsible for not running those jobs or not doing them consistently or some sort of works on my machine problem. You want to make sure that's deterministic, running in the cloud, runs every time, has retry mechanisms, all of this type of thing. And it's exactly the same as CI, but now we're just applying it for this sort of self-driving code base idea rather than for regular sort of just integration tasks as well. We sort of touched on security to a degree, and I think that's obviously now has become a very big topic for everyone on their mind, especially with these agents that can do a lot. Now we see a lot of people reaching for sandboxes, trying to contain these agents. There's also like context and connectivity. So connecting to their own internal systems, context, accessing databases. In their case, I think it was like Sentry, Datadog, things like that. How does someone then think about wiring up this type of infrastructure in a secure way? What's the sort of architecture, that allows these agents to access our internal systems without creating security problems?
So one way, and I do not recommend that you do this, but it's possible, is to take a bunch of API keys, stick them in a .env file, and somehow ship that to your agent, a Kubernetes secret or what have you. The main reason I do not suggest you do this is the agent now has access to a raw API key that it might put somewhere you don't want it to show up at. Surprisingly, a lot of folks start with that because also unsurprisingly, it's simple, it's easy. What you really want to think about is how can you give access to these systems in a way that leave you in control? So MCP and policies are one way to tackle this. Some systems don't have remote MCP servers, so I would abstain from local ones given the API keys, so you would want to use remote ones. Some systems don't have it, so you're back to a CLI. And so very quickly, what you end up with is an agent that needs to run arbitrary code. That needs to be true even if you want to, build and compile and test and whatnot, but also for access to other external systems. And at that point, you got to ask yourself, what protection does my kind of sandbox give me, the sandbox technology that I've chosen? And what we realize when talking to folks is that there is a lot of, dare I say, naivety about sandboxes. There's a lot of assumptions about, well, they're using this established Linux technology, it's AppArmor and SE Linux and whatnot, and maybe even BPF LSM. And they go, great, I'm secure then. They're using this really advanced stuff. But they're just labels. And as is a sandbox, there's a lot of really different technologies under the same moniker that do not provide the same kind of guarantees. The essence of all of this is, as you roll this agent out, you want to consider that you're giving an intelligence that is amoral, that doesn't care about your compliance and your wishes necessarily, or cares too much about your wishes in that it will tenaciously follow a particular goal you've given it, possibly to the detriment of what you had in mind, and that is so much smarter than the usual human attacker was. So in finding creative ways to bypass restrictions, sandboxes you might have put in place. And when you put all these things together, the very naive and even more slightly more advanced ways in that we secured workloads before no longer work. It's a lot of words to say that sandboxes aren't sandboxes. There are many differences between them. And you really want to carefully think about what does the agent have access to, even if this sandbox fails and if this layer of defense fails and if this layer of defense fails.
I know we also have within Owner, we have a few announcements in the next couple of days talking about some things that we're building here with regards to runtime security. But in essence, the industry is very early on this. You know, it's a big topic and one that there are no yet easy answers. But one thing is for sure that I think containing aspects of these agents into their own isolated environments, etc., obviously makes a lot of sense as opposed to like driving these on your machine, especially in the context of professional development or where IP or data or anything that you're particularly conscious about comes into it. And then on the landing page, we talk about these different sort of triggers. So scheduling them, having them, fire off on events for things like code review. Could you speak to that as well, Chris? Because I know through Owner, we have a feature called Owner Automations, which allows you effectively to do this. What are we sort of seeing, or what are you seeing from customers building on that now? What are the earliest sort of use cases that are emerging, or the insights that those customers are having about having the capability to run agents in this sort of decoupled from the developer individual in their workstation?
What we see is a form of progression of use cases. What most organizations start with is automating toil, automating the things that historically we have attempted to automate. An example of that is the upgrade of dependencies. Dependabot and the likes have in the past tried to do this too, but they were reasonably static in that all they did was bump a version in a package JSON, and if the API broke, it was yours to fix. Now, with agents, there's a lot more flexibility in that they'll also then fix the breaking API change and give you a tested and functioning PR instead of more work. That's where a lot of our customers start, is automating these baseline toil efforts. One of these efforts then is CVE mitigation. That is something that we see a lot, especially for larger organizations where they have a large backlog of vulnerabilities that they need to remediate within their code bases. Sometimes it's not even clear if the vulnerability affects the code base, but it needs to be verified. And here too, we see that agents can do a lot of the heavy lifting. Oftentimes, remediating a CVE is the same as upgrading a dependency, but you need to understand what to upgrade and if it actually solves it. And agents do a fine job here. We also see other stages, not just the changes of code, so all the toil essentially automated. We also see support and reviews. Automating code reviews is something that's immensely powerful. And here, of course, there are solutions that attempt this. What makes owner automations very powerful is that they don't just have access to your code base, but they also have access to other systems, for example, your issue tracker or your coding guidelines. It's the same system that can produce code that can now review it with the same knowledge. It can also actually execute that code. It's not the digital equivalent of a looks good to me review. We're not just looking at diffs. And that has significantly improved the quality of code reviews to a point where owner will add a label when it did not find evidence that this should be merged. Double negation. Owner will add a label when it has confidence that this change is good to go. And we have seen that meaningfully accelerate the time to review in our own practice and in that of our customers. We have like most organizations, very long backlog. We used to joke that, putting something into the backlog is a lie to our future selves. We know we'll never get to it. And what we've done is we have set up an owner automation that essentially once every hour wakes up, looks at something at the bottom of the backlog, assesses if it can meaningfully fix it and if it should still be fixed. And if so, we'll go and raise a pull request on it. And then Ona, the other automation, is going to go and review it. And that has made cutting down on the backlog very quick. And we've set up the same kind of automation, for example, for our error reporting system for Sentry. We have set up the same automation for Knip, which helps us trim dead code from our front end. We've set up the same kind of automation for metrics, where if we exceed thresholds, we get an analysis of why that is and potentially a fix for it. So we've used automations to drive changes through the code base that now no longer require manual or human investigation and interaction.
Okay, so everything we've discussed up until this point has been very theoretical. We're all in the theory. So what I want to do is show you an implementation, which is Ona, which I have access to. But if you want to have a look at Stripe and Ramp and what they did, absolutely you should do. There are many commonalities, but also some subtle differences between the implementations. And hopefully in future, we can update the microsite to spell this out a little bit further. Now, if I show you what my actual owner account looks like, you can see here, I'm in owner, and this is my project for the microsite. Now that's actually configured already with the dev environment is launched. And when I prompt owner and I give it an instruction, that actually then it spins up my environment and has my web server running, my Vipress docs, and even has Storybook. So the way that I've been actually building this project is I build my plans using Vipress. So if I grab that preview URL, we can see that in here. You can see all of the different specs related to the project. And if I go back, we can also then see what does Storybook look like. And Storybook is where I've been iterating with a lot of the visuals. So you can see the different fleet diagrams. You can see them in dark mode and light mode. And obviously then I go back and have been prompting with owner just to refine those, tweak those as we've been building out the microsite itself. Now, as you can see, we have all of this environment set up and running. So through owner, I can create new environments. I can give owner new prompts. I can run multiple things in parallel and all in the background in the cloud, which is amazing. That takes me almost the entire way to the self-driving code base, except for the final step, which is how do I now trigger these on schedules? How do I run these agents on a cron job or in response to a pull request or something like that? So let me just jump over into this demo organization and I'll show you how that works. Okay, so once you've got your environment set up in Owner, you can set up these automations and you can run those on these different triggers and things like that. So as you can see here, I've got some for code review. I've even got some that do maintenance for me that run on specific schedules. And I've even got some that can enforce Docker image best practices that you can execute across an entire organization. So if we go in and actually have a look, let's say at this code review one, we can see the different executions running over the past few days. And obviously if we click into those, we can explore the individual prompts for that particular agent, and we can go through all of the individual agent logs. Now, if I go back to the automation, I can go in and I can see how it works under the hood. So I have my different triggers, which could be manual. If this is launching a manual fleet of agents, could be based on a pull request or scheduled to run overnight or every Monday at 2 p.m., this kind of thing. Now, this one is a pull request trigger. What that means is on these different triggers, so when a pull request is opened or ready for review, this prompt is then executed that does a code review. That can then also be applied to a number of different repositories. So when you talk about agent fleets, we're also talking about the ability for a prompt or an agent to execute across every repository in your organization. This is really useful for things like standardization, for centralizing things like CVE remediation, things that are central to your company that not every developer particularly needs to know. And they would probably love to just happen when they wake up in the morning and it's just done for them. And that's how you can do that within Owner. Now, obviously in the different implementations, different companies, they will do that differently, but that's how we have done it. And that's how agent fleets look like within Owner. Once you've got that, and I'll just discard these changes and go back, through having these various different automations, and now if I filter again just for my own, we can then start to build up our own self-driving code base. We can build an agent that creates issues. We can then build an agent that picks up those issues and raises pull requests. And then by creating this entire system, you're building a self-driving code base or even a coding factory where everything or as much as possible is done without the human in the loop. And you can optimize and design how you want that to work and where you want the human to be in that loop. Within the existing systems that we have today, typically that's around your code review. So you want to have the code review as your human in the loop gate, where you're going to be reviewing any of those different changes. But that's a quick run through of how this looks in Owner. Let's get back into the conversation and talk through a few other bits. I think that's one of the common sort of criticisms or struggles with agents as well, is that they are very keen in sort of writing code, very keen in generating code, but not necessarily in pairing it back or helping out with maintenance and legacy. Is that also something that we are seeing from our side with automations that we're able to apply to those sort of use cases as well? Or is it that, these agents are only working more effectively in sort of greenfield applications as well?
The belief that agents are more likely to write code and are just these, like, for lack of better terms, code slop machines, I would say, is at this point a fairly outdated belief. It's a belief that comes from almost years back, previous generations of models and harnesses. It is not what we are seeing. What we're seeing instead is quite the opposite. Agents have become discerning at what code should still be there and what shouldn't. And we we project onto agents that they want to write more code. I'd argue it's humans who want to write code. It's the more senior engineers that pride themselves in removing it, but most engineers like to write code rather than remove it. Like, who wakes up in the morning and goes, great, today I'm going to clean up our code base? There are not many. Whereas agents don't care so much. They care more about how they're instructed. And so with automations, we have been able to meaningfully improve the quality, reduce code from our own code base, because it runs perpetually and because it runs in the background and because it is not something where someone needs to wake up and go, yes, today this is what I'm going to do.
Techniques that I like playing with myself as well as also defining specifications, I suppose, of like I call it long-term maintenance, but projects where I'm trying to get towards an outcome and I don't want to review a 20,000 line PR, but a series of much smaller PRs. And I find that to also be a really nice sort of function of automations, as well as waking up to a pull request that takes me towards a long-term technical debt or legacy related goal, but then doing it in small chunks whereby you can review it and kind of like chew through it individually.
So Ken Beck famously wrote about tidy first, the approach to first clean up your code base before you add something new. And that's what agents now enable you to do. If we're truly honest with ourselves, as humans, we value creating something new rather than cleaning up something old. And we can now have the best of both worlds. We can have agents do some of the cleanup for us and giving us more time to create the new shiny thing.
So, Chris just talked about agents being better at maintenance than humans, and one of the hardest versions of that is language migrations. COBOL to Java, or an older version of Java to a more modern version. And we'll show our agent fleets handle that in our use case session 3. So for, let's say, the engineering leader inside one of those organizations that is looking at background agents, is maybe sort of watching and following along, what would be your sort of advice to them about where to start in this with background agents? Would you start with a single team? Would you start by rolling this out across the organization? How might you sort of help them out in terms of finding a start point to on-ramping into background agents and towards this sort of self-driving code base future?
There are two key dimensions you need to consider. One is diffusion. So how do you bring this into your organization? How do you create maximum acceptance? Because it's no good at, as we all know, bringing in a new technology if it's not accepted. Even for something that requires reasonably little human intervention, its whole point, if these PRs then, for example, are considered slop or maybe are, then you're not making progress. So diffusion is one thing you want to consider. The other is, what part in your SDLC is actually slow? What is your bottleneck? What is the thing that is currently preventing you from shipping faster? And chances are it is not the production of code. Chances are it's not the actual creation of bytes on disk. It is more likely to be the review of this code, or the change failure rate in production, or your planning process in the beginning. So my advice would be, one, to understand what is your bottleneck? What is currently not moving quickly? And two, who in the organization do you start with? Who are your tastemakers? Who are the ones most likely to not only accept this, but embrace this new way of working? And a good measurement for this, the two go hand in hand. If you find the bottleneck and you find the team to whom this is really pain, and you go to them and can tell them, listen, I see this is what's blocking you right now from delivering on this project or shipping this feature. Here's how it's causing you pain. Here's what we can do about it. You got yourself a win-win. So looking at those two dimensions is how I'd start.
And actually, I would love to also come back to a topic we mentioned before as well around dev environments, right? So when I saw the Stripe and the Ramped post, obviously something that stood out to me is these are not companies that I haven't heard of before. The reason I've heard them is also we've been in the business of standardizing development environments for a long time, and these folks have been known in that industry. They have standardized their dev environment, have it in one command or one click. In many of these cases, these organizations, that's also in the cloud. So they've had a huge leg up there with regards to moving towards sort of background agents. But obviously, a lot of companies, pretty much most companies, will probably feel like we don't have a lot of standardization for our dev environments. You certainly can't stand up a dev environment with one command. It might be, hundreds of commands or tens of commands plus emailing someone, and sort of talking to someone in the office to get everything to work. For those types of companies, do you feel that then standardizing their dev environment is a good sort of fix your foundations first step? Or is there another way through? Or is there another path for them?
It is a non-optional step. It's a requirement. If what you're looking for is to have more agents do work for you, and it takes a day or two for each of these agents to get a dev environment, you're not going to meaningfully accelerate your SDLC. Having standardized development environments is really the core primitive that makes all of this work. Now, standardizing development environments is already incredibly helpful for humans, but again, it's necessary for agents. The challenge that we see some organizations have is that they are coming out of years of believing that it's the developer, like every developer for themselves. You go and figure out what tooling you want to use. Every team uses something else. At the very least, uses a different version of maybe the same technology. So we are also coming out of an era where there was a lot of freedom given to individuals and teams to the detriment of standardization. Now, I'm not suggesting that we take freedom away. I'm suggesting that we agree on a common way of working so that our now digital counterparts don't have to renegotiate the same thing over and over again.
Does this feel like a thing that then manifests in 2026, or are we multiple years away from this? Talk to me about the timelines. How do you see this playing out?
Getting to true self-driving code bases is obviously impacted by a lot of different dynamics that have to come together. One is the technology, and here we are very close, if not already there. Models and agents have become intelligent enough to converge on a code base, to not be divergent, to not track in a direction that isn't meaningful. The bigger picture is the connection of all the different systems that go into evolving a code base. It's not just your bug tracker, or it's not just your issue system and GitHub, and possibly your CI system. There's a lot more to it. There's a production system, there's a deployment system, there's a support system, there is all your observability in production. There's a lot more to it. And so integrating that together with the interaction of humans is a key challenge to making that self-driving vision a reality. The other is, even once all these problems are solved, diffusion is very real. Software engineering at this point has decades of processes and understandings and incumbent opinions on how software should be written. And it will take a long time for this art of the possible to diffuse through especially larger organizations and be truly accepted. My bet is that this will become, if not already is, an economic inevitability. But then I'm always surprised by the tenacity of humans in resisting change.
Thank you so much, Chris, for joining us. I hope this was helpful to you, and good luck to you all on your journey towards self-driving code bases. We'd love to know what you think. Please do tag us on social media or send us a message. We'd love to know your feedback and how things are going. So thank you very much. Thanks for watching, and we will see you soon.